Hello, 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 and welcome to Demonstration. All right, so that's me when I was much younger. Just kidding, that's not me. This is some dude on the internet. All right, so notice how we have a center of dilation and a scale factor. Scale factor is 1.7. So 1.7 is not 2, like we saw with the photocopier and the other assignment. So it's only 1.7 times farther. So this is 70% further along, which is annoying. So I like to change this. Where's my scale factor? Get in here. Change this to 2. We've seen 2. Let's do 3. Bang. Okay. So it's way bigger. And if I zoom out and put the center over here, and bring this over here, you can see that dilation's definitely, the center is called the center for a reason. Everything goes away from there. And if you want something to dilate away from itself and expand out like a marshmallow, like Brunel was supposed to do with the photocopier, you put the center of dilation right in the middle. Then it expands out from there. And now when you change the scale factor, it'll just push out from the center, bigger and bigger, the bigger the scale factor. Okay, why is this dot so big? Seriously? Let's make the center smaller. Okay, and you can also move the pre-image. When you move the pre-image around, the post-image, or what we call the image, also moves, because there's a rule that is moving every point in this dude's face. It does kind of look like me, actually. There's a rule that moves every point in this dude's face out to this point in the image face. Okay, and it's pretty cool. It is flawless. I mean, it's seamless. It's continuous. The flow of the rule moves around from the center through the picture out to the dude. I'll leave a link to this toy. You can play with it. Um, there's also some other things. No, that's lame. This is kind of interesting. You can change the scale factor, sometimes called K. I'm going to boost it up. I don't like. And then you move around point B, and that red point is B prime. Although it's a little clippity. I think it snaps too much. So if you make a shape, a green shape here, it makes a red shape that is 2.4 times further away from A, but also 2.4 times bigger. So if we measure the green shape from top to bottom, it's like less than 1 box tall. But if you measure the red shape from top to bottom, it's 2 plus tall. Let's make this. Let's do it for real. From there to there. Okay. From that dot, which is this red dot corresponding, to this dot, which is this red dot corresponding, it's 1 box here, but it's 2.4 over here. So distances are scaled up by the scale factor, both within the image and also from the center. Distances from the center are 2.4 times longer than they were for the green guy. All right. Anything else? Whoa, that's weird. This is related to dilation, but there's also rotation going on, so annoying. Okay, let's get back to, I don't know what I'm getting back to. Oh yeah, this one, same thing. Oh, let's do 0 turn, and now, okay, there we go. This is dilation. This is actually dilation. Can we make the K negative? Here's 1. What's happening at 1? Oh, there's nothing. There's no image. It's just the same as the pre-image because everything's 1 unit or 1 times farther away, which is 1 times farther away is the same farther away, same farther awayness. And now K is 0.9, so it's getting closer. It's getting smaller. Why are there so many? Can I get rid of this? Because I think this first one is the one that's at 0.83. And then each other color is 0.83 smaller, smaller, smaller. Jeez, that's annoying. Why is there so many? Okay, now this first one is 0.39. Let's get half as big. Let's go to 0.5. 0.5. This first one is half the size as that, and it's half the way to the center of dilation. What I want to show you is what happens when you go negative, which they will not let me do. So I'm an idiot. Let's try one more thing. Dilation. Nope. Pirate ship. No. Here we go. Not the pirate ship, man. Why is it gotta be? Here we go. All right. So where's my scale factor? Negative 1.75. All right. What happened? Well, instead of going further, the points are actually brought back and reversed 1.7 times farther from the center. So negative scale factors will flip things over. It's kind of fun. It's kind of fun and funny like that. Right? Does that make sense? Okay, we don't see very many negative scale factors, but they exist. Let's just roll down here real quick so you can see the scale factor negative 1.7. The dude's upside. Why is he upside down? Well, because if you draw a line from his eyeball to the center and continue it, now it's down here. And if you draw a line from his chin up to the center and beyond, now it's up there. So what is above becomes below. What's below becomes above. This is actually how a camera lens works. The camera lens is a tiny little hole that light goes through in straight lines, and it ends up upside down on the other side. It's also how our eyes work. But both cameras and our eyes are able to flip the image afterwards. So our brains just interpret the image right side up. Cameras flip the image right side up. So pretty cool. Cameras are like scale factors. They turn the big. Yeah, if you think about it, a picture is just a tiny version of the world that's been scaled down by a scale factor through a tiny hole with straight lines. All right, that's enough of this funny video. I should make you do a little quiz. Yeah, quiz time.